Let's take a look at some new malware uploaded to Malware Bazaar. So this was uploaded by Rex CZ, and Rex actually hit me up on LinkedIn and said, hey, I've got this bit of malware that I was sent on Discord. Do you want to take a look at it and reverse it with me? Now, he's put a comment in here with the password, which is Malinu Beta. And because this was distributed via Discord, my thoughts immediately went to, this is likely one of those Electron or Node type samples that are posing as a game. And as you can see here, he's also given the link that it came from. Let's take a look at the link. Oh, Molino game. Nice. It's a beautiful game about a person getting food or fruit or... Look, I don't even know exactly what this is, but it's not a game, it's malware. So let's dive into it. So I've downloaded the sample here and we've got Molino game and it is an archive. So let's extract this and we're going to give it the password, Molino Beta. And quite often, a lot of these scams are going to use the game name plus beta or alpha as the password because it's pretty easy to remember and it's a way that they can continuously have a universal type of password that they send to people. So we've got the game and we got the game set up here now as well. Now, let's zoom into this. You might notice we have NSIS. So that is an installer that we can extract using 7-zip. So let's go ahead and use 7-zip and extract this installer onto the endpoint. Now we extract the installer, now we get the plugins directory, and we also get the uninstaller here. Let's go into the plugins directory. We have done this before. If you haven't seen my initial video on Discord malware being transmitted, take a look. I'll leave a link in the description so you can check that one out. But we've got the app here, and that is the 7-zip archive. We can just once again extract that 7-zip archive. And now we've got our files. And Molino game here, you can see once again, it's an Electron application, and this is going to have 0 virus total detections. It says it's come from, Unreal Engine. This is going to use the resources that we have here though. So we can actually look at the resources and you can see there is an unpacked version here that's come with it and the node modules. Interestingly enough, this has only got 2 modules, SQLite 3 and iLovingCats. Now, I've never heard of iLovingCats before, so let's give this a sus. We're going to open it up. And it does look like it's using a number of other files. It does look like it's using a number of other dependencies as well. And it's available on the NPM website. So if we take a look at the distribution that comes to this index.js, you'll notice that this is using Depapi. So immediately I begin to think, hey, maybe this is going to be getting the master key that's used to secure credentials on an endpoint, something that we want to be aware of. We can see node.jip build, and in the source, we can see a number of C++ classes, particularly the Depapi classes and the main one here. And we can see that this is using protect and unprotect data functions. Yes, this is going to be used to get the key used to encrypt and decrypt credentials on a system. Definitely something that's interesting and not something you would want to see in the context of an Electron game. So let's dive into this a bit further. So taking a look at the NPM package iLovingCats, there was actually an advisory that got put out 2 days ago that anything that's using this node package should be considered compromised. It looks like maybe the malware author has created this package and put it on a node package manager, not necessarily to just make a malicious package there, but to try to obfuscate the use of the Depapi package. I'm not 100% sure, but either way, it's been taken down. Basically, now what we're going to do is we're going to use npx to run an Electron package of ASAR and then use that to extract the code that we have here. So in our resources, we have the app.asar. And if you've seen my previous video, you'll know how this works, but let's run through it again. We're going to use npx. We're going to do Electron. Whoopsie daisy. We're going to use npx. We're going to do Electron. We're going to do ASAR. We're going to do extract. We're going to specify app.asar, and we're just going to put it into a folder called extracted. And you can see that's successfully completed. So now we've got the folder called extracted, and we really have the crux of what we want to see here. So there's the node packages that this relies on, and you can see there is quite a lot of different node packages in here. You will notice that there's not actually Depapi by the looks of things. Yeah, so you can see it doesn't actually directly import the Depapi package. And we also have this JavaScript. Now this has a unique name, to say the least, and the package.json file. We'll first look at the package.json file, and we can see that it's using these dependencies, including the iLovingCats version 1.3.1 or higher. And we can see that when it runs, it's going to run this as the main application. So we want to understand what's in that JavaScript. So if we look at this JavaScript and we edit this, oh dear, it's obfuscated JavaScript. It's dirty, it's ugly, it's hideous. And it does look like there's some breaking up of perhaps a base64 encoded string here at the end. Let's see what we can do with this. There's a good chance that they're not actually doing anything kind of unique in the way that they're obfuscating this, and they've used a publicly available obfuscator. So let's see if we can deobfuscate it using that. So I've gone to the obfuscator.io deobfuscator, and I'm just going to plonk this in and hit deobfuscate. And it's running through, performing a lot of the deobfuscation functions. And after a short period of time, we do have the output here. Interesting. Let's see what we've got to work from. So I've saved the file called deob1. Now, it does look like most of the script is actually in this base64 encoded blob, but it doesn't seem to be just base64 because this is passed with a few other parameters here. So we're going to have to dive into this to try to get the last part of the script and understand what it's doing. So one of the things I immediately notice here is what seems to be some level of encryption. The reason being is because we have this pbkdf2 sync and create cipher IV. We also have reference to AES 256 CBC here, which definitely makes me think that this is encrypted using AES. Now, if I was to look up those classes, we can actually see that pbkdf2 sync has a number of parameters that are passed to it, and create cipher IV also has a number of parameters that are passed to it. So let's actually see if we can perform the decryption of this and get some more script that we can actually understand. So I've opened up 3 instances of CyberChef, and the reason being is because I really want one that is deriving the PBKDF key, one that is using the PBKDF key for the decryption, and one that's just a bit of a scratch pad in case I need to convert any kind of numbers from base 16 to base 10 or so forth. So let's see what we can do here. So it does look like there are a number of functions. Number one, we have this constant variable defined, so we can see that that function has a number of parameters, 1, 2, 3, 4 being passed to it. This first parameter, if we look at what this is, seems to be referencing a variable here that is looking at base 64 and UTF, so probably something to do with the decryption there. This one is going to be the actual PBKDF key, so definitely something of interest. This one is going to be also used in that same function, and I'm assuming the other one is as well. Yep, so the other one is down here with AES as well. Let's first look at deriving the PBKDF key. Now, to do that, we need to know a password, a salt, the iterations, key length, and digest. So let's actually start with this PBKDF2 sync and see what's being passed to it. So we have PBKDF2 sync. Now, this would be the first value being passed to it. These would be the next values, and so on and so forth. So this value here is defined as the second one that's passed to this function. And if we look at this function, it's this. So it's going to be the second value that's passed to it here. So if I scroll all the way down, the first value seems to be this blob, this base64 encoded blob. The second value seems to be this. So this is going to be, and let's just see, it's going to be the password that we use to derive the PBKDF key. So we're going to do PBKDF, derive PBKDF key, and we're going to use that as the passphrase. And this does look like it was UTF-8. Now we have the second value being passed to it. The second value is going to be base64 from this. And this is going to be the third value passed. So the third value passed here is going to be this one right here. So this is going to be our salt. And this is going to be in base64. And we can tell that. Now we go back. And we're just going to work through this logically one step at a time. So now we have the first value, the second value from base64. We have the third value here. Now, the third value in the PBKDF2 sync is going to be the number of iterations. So this in base 16. The number of iterations here, though, is not in base 16. We actually have to convert that. So let's go over here, and we're going to make this 2 base we'll change it to base 10, and we get the value 10,000. So 10,000 is going to be the number of iterations that we're using here. Now let's take a look at the key size and the hashing function. So we do have 0x20 and SHA-512. So SHA-512 is going to be the hashing function. 0x20 is going to be 32. So that's the size of the key that we should be getting by the end of our output here. Now, this is actually in hexadecimal. So even though this has an output length here of 32, this output length, it actually has to be double that, which means this key size should actually be 256. So now we get this output, which is 64 in length. It is in hexadecimal, that is the output, which means that this is a 32 size key. And if we actually go back and we're not too sure about this, we need to remember that this is using AES 256, so it needs to be 256. So now let's go over to our AES decryption. We're going to take our key, which we just got then. We know that is in hexadecimal. We're going to have it in CBC. We're going to have the input as raw. We'll do raw, which means we will need to do base 64 from base 64 because we can see base 64 is what's being fed into it with that large blob. The initialization vector we have to look at here now. So the create cipher, the third value is the initialization vector. So the third value in create cipher, 1, 2, 3, we have this as the buffer. This is the final value that's being passed to that function. So the final value here is this one. So let's take that. We're going to put this in. We're going to make it base 64 because that's what it is. And now you'll see that it's not coming up with an error, but we're not actually getting any output because we haven't given it that blob yet. And we know that blob has to be the last thing that's being passed to this. So let's take this data and see if we can do a successful decryption here. So nothing else seems to be done with this. So it's not like it's going through any more changes before it's put in. And bada bing, bada boom, we actually get some script output. So let's take this script output and see what we're left with. So I'm going to create a new file. I'm going to put this in. And it does look like there's more things starting to look like they're in English, but there's still a level of obfuscation. Now let's see if we can just run that same deobfuscation tool because we know that they were using publicly available obfuscator here for the first iteration. So maybe they're doing it for the second iteration. Let's take it in here. Let's replace this, deobfuscate. And just like that, it looks like we have the malware. We have the malicious script. So let's dive into this. Let's actually see now that we can read it and understand what it's doing. Now this is actually like 3,000 lines, so let's see how fast we can go through it. We can see that there's some constants defined, exec, exec file, exec sync, exec spawn. So it does look like this has the ability to run child processes that are passed down it. So that's the rat capability. It does look like it's probably got some hard-coded IP addresses. This could be C2 or it could actually be that these are known IP addresses for sandboxes. You can see there's a constant here mentioned as well, where it's specifying that Depapi is coming from the I Loving Cats module, which is what we saw before. So based on some of these names, it could be that these are known to be in particular sandbox environments. You can see that there's a number of tools for analysis, dynamic analysis. So if you've got Postman, Telerik, Fiddler, you've got x64 debug, Binary Ninja, these are kind of like hard-coded or, ones that they've included in this script that if any of these processes are found, to say no, it doesn't want to run. There is also this message saying this program does not run on virtual machines. Kind of funny because we don't need it to run. We can just look at the script. Thank you very much. There is also a fake error capability, which says error executing VB script and then a message. So I'm guessing this is a way to just throw people off the scent that maybe it's not been able to run the game properly. These system names are fairly interesting. It could be, that these are just known sandboxes and these IP addresses. We can actually see where this constant's being used. So we can do a Control F and you can see, yep, this is a blacklisted IP address. So if this does an IP lookup and it's from known sandboxes or known devices that they said, no, this is blacklisted or blocklisted, we do not want this to run, that's it. It's going to then run this function, which I'm assuming is it just terminating itself. Here's the definition. So you can see if it's detected any of those things, it's going to give that fake message when it exits itself to say, hey, there was an error executing the Visual Basic script. So there are particular usernames that it doesn't want. So if this includes that, so we have to look at this. So that's the WDAG utility account and runner admin. So if anyone with those usernames are running, it's going to say no. And we can assume that all of these are going to be anti-VM or anti-analysis type checks. You can also see it's looking at whether it's running on Hyper-V, whether it's got any kind of GPUs. It's also looking at particular operating systems this is running on, things that maybe just aren't quite right, the total memory assigned to it. So there's so many anti-virtual machine or anti-analysis techniques that are built into this script to try to stop sandboxes and antivirus products and reverse engineers from actually picking up on what this is doing. We can see it does have a number of locations where cookies and browser credentials would be stored for a number of different pieces of software. So Brave browser, Yandex browser, we also have Google Chrome, etc., etc. And you can see that it is getting cookies from those browsers. So it definitely wants to be stealing that. It also looks like it's stealing Roblox sessions cookies. So maybe it's stealing access to people's Roblox accounts. You know, a lot of script kiddies or less skilled individuals are using this type of malware. So it's not surprising that maybe they want to be stealing access to people's video game accounts as well. And obviously this being transmitted over Discord means that is hitting their target victim demographic there as well. It's stealing Mozilla Firefox cookies and login data, credentials, getting all the stuff that automatically is saved to your browser. So if you are logging on with your browser and you say, save my credentials or autofill whenever I go to this website, it's stealing that as well. We also see evidence of it doing the decryption required to get those passwords. What else do we have here? Yep, your autofill data. That's where that one is. Stealing cookies, killing browsers. I'm not entirely sure why it's killing browsers here. Maybe it is unable to gain access to certain things while the browsers are running. It's also storing something in your temp directory in a folder TMP that is likely going to have all the data that it's extracting and getting ready to exfil. So your autofill, your cookies, your passwords, etc. Because you can see it is storing this in a zip archive, and then it's uploading them to different locations. And here we actually see the first evidence of what malware family this is perpetrating to be. So this is Leet stealer. Now there is a lot of overlap with other things that I've seen here and reported on. You know, for example, lots of these Electron application pieces of malware. There's Leet stealer, there's Duvet stealer, you know, Celestial stealer, there's Hexon, I believe it is as well. And so many more that are all just being transmitted and communicated on through Telegram channels. And you can really just find out what these are and what they are doing in those Telegram channels. And so not surprisingly, if I go to a Telegram viewer, I can see reference to Leet stealer as one of the channels. And there is Leet here with the clown emoji. You can see 359 subscribers. It just says Leet. And it's not surprising. And this is almost certainly Leet stealer because we can see the clown emoji here as well. It is nice because there are particular, you know, C2 information and APIs that are mentioned here, including keys used to access them. So I definitely wouldn't recommend anyone use that key to access this Discord bot. And if I take a look at the particular subdomain on the iwannaeatcats.com, I want to eat cats, man. Come on. You said you love cats. I loving cats. Now you say you want to eat cats. I am shooketh. And we can actually see a community comment saying, this guy's going around sending rats on Discord, part of his C2 exfiltration infrastructure, I guess. You are not wrong there, hello 123451. You are not wrong at all. And it's pretty interesting. We can actually see that on digipress.club, which I believe, yeah, it looks like our hosted instance of Mastodon. It looks like someone was talking about this on this Mastodon instance. Foon. Fairly well-known individual. So they have been talking about this malware as well and talking a little bit about what it's doing, I guess. Yep, there's the I Want to Eat Cats site, sets up auto run on next boot, also grabs an npm package for unknown reasons, obfuscated and encrypted, decrypts itself on run. The encrypted code is also obfuscated. Yep. It does most of the stealing. Yep. It looks like they were actually the individual or this individual here, maybe as well, were the ones that got the I Loving Cats repository taken down. So fair play, well done. I appreciate your work. Let's continue checking out exactly what this does. So it's sending data to this said Discord URI. There is also mention here, yep, uploading the files, stealing data, once again, stealing data, same API keys being included. Cookies, other than those in Chromium bypass. So try the cookies in the folder I mentioned if they do not work. This is a problem with the victim. There's not a problem with the victim. There's a problem with you people for targeting the victim. So there's not a problem with the victim. Anyway, we can see it's killing. So it's using task kill to kill particular processes. So any of these particular processes, it's going to kill them. Does it like it's exfiltrating to particular services here. So gofile.io, uploading files to there. File.io, uploading files to there. Catbox.moe, no idea what catbox.moe is. Maybe this is another publicly available service, or maybe something run by the same person that keeps talking about loving cats or wanting to eat cats, you know, whoever is using this particular piece of malware. And we have it here, looking once again at different directories. We do have Discord, so this is likely to be impacting your Discord instance to steal your Discord credentials as well, and maybe even embedding a level of MFA bypass or script within that to be able to steal your MFA prompts if they're there as well. We can see discord.txt. We can see it getting information about the user they have infected. So this is going to be used to actually send back to the C2 to say, hey, here's their Discord details. Username, discriminator, email, phone number, whether they've got MFA enabled, etc., all pulled from the Discord API. Now we also have reference, yep, similar references to what we saw before. Discord. Billing information, you know, any tokens that can be used, whether they've got Nitro, whether they're, you know, what their IP address, phone number tied to it is as well. Any HQ details. So really, you know, interested in like gamers here with this stealer, right? But I mean, it's not the only thing they're stealing. You can see it is stealing stuff from their browsers as well. So it's not just stealing from their Discord instance. So yeah, this is looks to be this Leet stealer. Once again, we have it posting, making the request here. Seems to be a few cyclic things here, doing similar things. This is interpreting if they've got PayPal set up for their Discord Nitro. This is getting their externally facing IP address, so myexternalip.com. I mean, is this being used to infer whether they've got that IP address for whether it's on the block list? Hang on, I just want to see something. So we've got this, and this is being used here. Why are they using multiple API services unless they've ripped off some code from some other, you know, repository, or they have some level of redundancy involved here? Because here they're getting the publicly facing IP address from api.ipify.com. What we saw before, they're actually not getting it from ipify.com at all. They're getting it from myexternalip.com. So it's pretty interesting that they're using two different, you know, web services to enumerate their publicly facing IP address. Yeah, I can't see the real reason of doing that unless they, you know, wanted to have that level of redundancy if it couldn't get out to one of those, but it doesn't even look like it's been set up like that either. Kind of just looks like they've ripped off the code from someone else, which is not surprising, to be honest. A lot of these just copy code from everyone else, and they're all doing similar things. They're all stealing similar types of information. What else have we got? Yep, all stuff to do with Discord Nitro, etc., Firefox. This looks like it's actually getting crypto wallets that they've got as well. You know, these information stealers go after whatever they can. So it's looking at extensions on your browsers. And if those extensions for particular crypto wallets are there, it's probably going to be trying to grab that data so then it can get access to your seeds and get access to your crypto wallets as well. This is funny. What is this being used for? These look like really common passwords, like I love you and Batman and hello123. So I'm just wondering what this is actually used for. Returning that password. What's this? Read file sync. What is it? So it reads something and then it returns it, and hold up. And if it can't split it, it returns that array. So it's joining. So it's joining all your stuff into a file called this. This is a hard-coded file name, x7, etc. And if that fails, it's just like writing this array of just shit passwords. Why? I don't know. Got stuff in other languages here as well. Like, I can't tell who this is supposed to be supporting here. Like, has this been code, once again, that's been ripped off from someone else? Like, what does this even translate to? First 16 bytes of the file in Turkish. So why have they got debug messages in Turkish when their other debug messages are in English? Like pick a language here that you're working with, unless you're just, yeah, like I said, ripping off code from other malware authors that are doing the same kind of thing. Turkish again, password tried. Password tried. Interesting. Maybe it's actually trying to use these. That'd be interesting. Maybe it's writing them to this file because this file may then be used in a brute force attempt. So if that exists, it reads that file, splits them, and that is going to be stored there. That is going to be returned for this. So this is used. Where constants this, and this is for that. Yeah. So for this in this, so this is for every entry that's in that file. It's going to be based on this debug message. Password attempting to use that password in some way, shape, or form. I'm guessing that this is the function that's actually doing it. Yeah, so it looks like it's returning something trying to decrypt the data with the two variables that are given. So this is Seco file, so it's using that, and it's using decrypt data. So the first value that's given and the second value that's given. The first value that's given is this. And this is reading from this. And that's your seed path. It actually takes the passwords that it gathered from your browser, splits them up, and it's trying to use them to brute force your seed for your crypto wallets. And if you don't have any passwords, it's actually just going to try really, really basic ones that are configured here. So if your crypto wallets use any of these passwords, it's still going to be successful, even if it wasn't able to extract that in the previous attempt. Interesting. So they got some brute forcing of your crypto wallets, have the exfiltration of data. They have click to view profile. Yeah, so this is all being pumped up to their C2 as well to say, here's the games that they own, here's the account when it was created, etc., etc. Kind of funny that there's some hard-coded names here: Growtopia, Minecraft, Epic Games Launcher, WhatsApp, Telegram. So probably, once again, trying to get data associated with those applications if they're on the computer. It goes, yep, no worries, found them, upload them. Leet stealer. The reason why you'll see this repeated is because they don't know how to use one constant value and function and actually just reuse it. It just looks like they're throwing out, yeah, at least in the decrypted JavaScript here, they're just throwing out and redefining the same things that they want to say. So they want to say, found files, and here's your username. When in fact, they could just make this method, pass it the value that's stolen, and be like, found X or Y, and not redefine this over and over and over again. But I digress. Like I said, they're just likely ripping off code from other malware authors and publicly available projects like Epsilon Stealer. So they're going through, zeroed out token database file. Cool. I want to eat cats. That's nice. Interesting enough, this is a little bit different. So this has got download and panel, and it's getting a stream from that. So that would actually be interesting to know what that brings down, because it does look like this is maybe bringing down another executable, because it is defining random bytes and then giving it an exe extension. Very interesting. Data pipe, finish error. And then this is where it's actually running it. So this would be it deploying some sort of executable from that C2 server on the endpoint as well. So this is the ability to run those extra executables and extended functionality by pushing down whatever they want from the command and control server. So I just want to see if this is the same Turkish language. Portuguese now? What is the debugging messages here? Is it in Portuguese? Is it in Turkish? Is it in English? They can't decide. This is interesting. They are spawning an instance with this remote debugging port specified, with remote allow origin specified as well. This is a way to spawn a Chromium session. Now that Chromium has the app-based level of encryption to prevent people from stealing the cookies, what threat actors have started to do is spawning headless sessions of the Chrome instance with a debugger that they can then connect to that debugger WebSocket and dump out all those cookies and sessions directly from the browser itself. And you can see it actually happening here. It's really kind of interesting that we've got this in a script format, because it just makes it so much easier to actually see what they're doing. They're spawning an instance of it on localhost, they're connecting to it, they're connecting to the WebSocket, and then they're stealing it. And it could be that these debug messages are literally because they copied this code from someone else, right? It's not hard to plagiarize JavaScript code from another individual. Network getting all the cookies, and there you go, cookies got. And then Roblox sessions, once again, Chromium bypass, Opera bypass, starting a browser session, and cookie. Look, I love that. That's in English. Why have you swapped back to English? Processing browser, stealing the cookies, session ID is undefined. Yep, Roblox, once again, trying to get the Roblox session. And then we can see it's actually doing stuff to do with Roblox as well. Probably checking how much in-game money they have for that as well. Yeah, you can see all the purchases that it's enumerating here. Uploading the file. And once again, let's just redefine this constant variable, because why not? Posting, yep. Once again, don't put this in any kind of, variable that you can reference. Just keep specifying it over and over in your script. Minecraft, user cache. Must be to do with Minecraft, name MC, so that's name Minecraft, maybe in Minecraft heads.net. So maybe this is actually used to enumerate their Minecraft user information. Either way, it's stealing Minecraft stuff. Task kill, killing Minecraft processes, Luna client, Minecraft sessions, sending to the Discord, Minecraft session, blah, blah, blah. Once again, app.asar. So this is actually bringing in another ASAR module by the looks of things, atomic.asar. And then it looks like it's mentioning Exodus wallet. So maybe it's got something to do with that as well. Exodus.asar. Maybe these are used for stealing stuff from those crypto wallets. Like, there's just so much that it's pulling down, right? DC inject message. Not sure what the DC is meant to be referencing here, but you can see injection, successful injection. So it's using this key to pull down what's required to do some level of injection, possibly. I'm not actually seeing where the injection occurs at the moment. URL is not responding. That. So this pulls it down. That is data pipe, await new promise. Pipe on that, error, finish. Not sure what this new promise is. Maybe this is how the injection is occurring. Either way, the debug messages kind of give you a good idea on what it's doing. So browser processes, fetching WebSockets once again, killing processes once again, stealing cookies once again. SQLite, so opening up SQLite databases, probably for Opera. Get DSC tokens. What is DNC? Kill DSC? This Discord? Oh, of course it's Discord. Yeah, so I don't necessarily think it's injecting into the Discord process. It could be, but it's more likely to be injecting into the Discord client some level of JavaScript, like I said, that then is going to be able to be used to get the MFA tokens and intercept particular messages that are sent through it, or particular, authentication tokens that are prompted for in that as well. Yeah, I reckon that's what we're looking at here. So stealing Discord tokens and killing Discord info, etc. So downloading exe, added to startup successfully. So this is where it's establishing persistence on the endpoint. And this is the execution of all the tasks when it seems to start. So it goes ahead, runs all these different functions, does all these different things. And here we are. That is the end of the stealer here. So we know that that was Leet stealer. It was pretty easy to analyze once we knew what we were doing, once we had the decryption capability in play, and it just gave us everything that we needed. So whilst the installer for the game is beginning to get AV detections, it does look like it's also been classed as Leet stealer by none other than Kaspersky. But if we're just looking at the game executable, completely undetected, very large, 164, because the malicious code, once again, is in that script. It's in the Electron application code that gets interpreted by this executable. But this isn't just one of these. There's so many of these that carbon copy, rip each other off, steal code, compete with one another on these Telegram channels. And whenever they come out with a new variant of their game here that they send to people on Discord, it's largely undetected by AV vendors, except for AV vendors that probably have a level of heuristics or have a level of analysis that's being done on the Electron scripts themselves when they occur in memory and are done in an environment that is not already being blocklisted by the scripts being executed. Thanks so much as always. Let me know your thoughts, feelings, comments, anything else in the comment section below, and I will catch you next time.